All right, let's talk about something that's literally running our world, but that most of us never even see. The database. Yeah, from the pictures you post online to the money in your bank account, these things are the invisible engines behind it all. So let's dive in and figure out what they're all about.
Does this look familiar? Come on, we've all been there. This folder, this absolute mess, it's the perfect way to understand a huge problem. How do you keep track of information so you can actually find it and trust that it's the right version? Well, that digital headache is the exact reason databases were invented in the first place.
So let's rewind a bit. Before we had these slick databases, the only option was a simple file system. And that's basically just folders filled with documents. Kind of like that messy reports folder, but on a massive scale. Let's see why that becomes a total nightmare fast.
So this whole file system thing, it creates a bunch of headaches. First up, data redundancy. Just imagine you have a customer's address saved in your sales file, your shipping file, and your marketing file. If they move, you have to find and update it in 3 different places. Miss one and everything's out of sync. Then you've got concurrent access problems. If 2 people need to update inventory, one person gets locked out while the other's working. Talk about a bottleneck. And security? Forget about it. It's pretty much all or nothing. You either see the whole file or you see none of it. Good luck trying to hide sensitive data.
Let's really paint a picture here. Think about a big online store. You've got products, customers, orders. Can you imagine trying to run that with thousands of separate text files? It's impossible. Someone buys the last pair of shoes. How do you update the inventory.txt file fast enough so someone else doesn't buy it a second later? It's a complete disaster waiting to happen. Clearly, we needed a better way.
And that better way, the elegant solution to all this chaos, is the database. And it's all managed by software that acts like a super smart, super strict gatekeeper for all the information.
So what is a database, really? Forget the jargon for a second. It's not just a big pile of data. The 2 key words are right here: organized and structured. It's a system that's designed from the ground up to bring order to information chaos.
And this is a really important point. If the database is the neatly organized library, the database management system, or DBMS, is the master librarian. It's the software that does all the heavy lifting. It lets you in, makes sure you follow the rules, finds what you're looking for, and keeps everything safe. You don't just walk in and mess with the data directly. No, you make a request to the DBMS and it handles everything for you.
And check this out. This really puts it all into perspective. On the left, you've got the old way, a messy, inefficient, insecure free-for-all. And on the right, the database approach, structured, secure, efficient, and built for lots of people to use at once without causing problems. The difference is night and day. It's a complete shift from chaos to control.
All right, so how does a database actually create all this wonderful order? Well, it all starts with a really simple but super powerful idea: using tables as blueprints for our data.
Okay, take a look at this simple table. It's for tracking which student is in which course. Seems easy enough, but wait a second. See that? We have John Smith in History 101. Twice. Uh-oh. Is that one student who was accidentally entered 2 times? Or is it 2 different students who just happen to be named John Smith? Right now, we have no idea. We're stuck.
And this brings us to one of the most fundamental questions in the entire field. How in the world can we make absolutely sure that every single entry, every row in our table is 100% unique?
The answer is a beautifully simple concept called a primary key. You can think of it like a serial number or a unique license plate for every single row of data. It's a special column where every value has to be unique and it can't ever be empty. It's the ultimate identifier.
And boom, look at this. All we did was add one new column, SID, for student ID, and made it the primary key. Problem solved instantly. It's crystal clear that student 101 and student 102 are 2 different people. All that ambiguity? Gone. Every record is now perfectly, uniquely identified.
Okay, so giving every record a unique ID is a huge step forward. But that's just the beginning. To be truly efficient and trustworthy, databases need to follow a few more rules to keep the data squeaky clean.
This whole process has a kind of nerdy, intimidating name: normalization. But don't let the word fool you. The goal is dead simple. Get rid of data redundancy. Remember our problem with the customer's address being in 3 different files? Normalization is basically the rule book for making sure that never happens. See, because when you repeat data all over the place, you get these weird, buggy situations called anomalies. For example, an update anomaly is when you change an address in one spot, but you forget to change it in another. An insertion anomaly is a weird one where you can't add a new course to the schedule until at least one student signs up for it. And a deletion anomaly is the scary opposite. If the last student drops a class, the entire record of that class might just disappear from the system. It's a mess.
So the solution, the guiding principle of good design, is this. Every single piece of information gets one and only one home. The student's address lives in one spot, the course name lives in one spot. This creates what's known as a single source of truth.
Now, being organized is great. It's fantastic. But the real true superpower of a database management system is making sure that every single thing you do is absolutely 100% reliable, even if the building's power cuts out halfway through. And this superpower comes from a concept called a transaction. You can think of a transaction as a package deal. It's a set of actions that have to either all succeed or all fail together. It's an all or nothing pact.
The classic example is a bank transfer. Think about it. You're moving money from savings to checking. That's really 2 steps. Take money out of savings and then put money into checking. But what if the system crashes right in the middle? The money is out of your savings, but it's not in your checking yet. It just vanished into thin air. That would be very bad. Transactions prevent this nightmare.
This rock-solid reliability is guaranteed by 4 promises, and they go by the awesome acronym ASAD. A is for atomicity. That's the all-or-nothing promise. The transfer completes, or it's like it never even started. C is for consistency, meaning the database's rules are never broken. I is for isolation, which ensures that if 2 transfers are happening at once, they can't interfere and mess each other up. And D is for durability. That means once the bank says the transfer is done, it's done. The change is permanent and will survive a crash.
And there you have it. That's the whole journey, right? We went from a chaotic mess of random files to a super organized, incredibly reliable system for handling our most important information. That is the power of a database management system. And don't underestimate how huge this is. Some estimates say that around 95% of all the data in the world is managed by these systems. Think about that for a second. They are the quiet, invisible pillars holding up our entire digital civilization. So I'll just leave you with this final thought. Everything we do in our digital lives is built on these simple, fundamental rules. Rules like atomicity and primary keys. Our world relies on those guarantees. So what happens if, for whatever reason, those guarantees, those pillars, start to crack? It's definitely something to think about. Thanks for joining me.